In this video, we are going to have a look at the vector equation of a line and how it relates to some common IB Maths exam questions. So I've given you two coordinates, and these are just coordinates on a three-dimensional plane. Where coordinate A is a point, where 1, 2, and 3, and coordinate B is 5, 4, -2. Now, what we're going to do is we're going to find the vector equation of a line that passes through both of these 2 points. Now, we have probably seen a similar topic to this before when we did coordinate geometry, which may have been a couple of years ago. And coordinate geometry, we found equations of lines. And the equation of a line was in the form of y equals mx plus c, where if we had an xy axis, we could find the equation of any line. And c was the y-intercept, which was some point that we knew our line passed through, and m was the gradient, which told us the direction that the line then travels. And they're the two things that we needed. We needed a direction, which is the gradient, and we needed some point, which was often given in our questions. And it's actually very similar to the vector equation of a line. So the vector equation of a line, the general formula, which is given in our formula booklet, is this one here, where r equals a plus tb. And it's very similar to y equals, I'm going to put the c first, c plus mx. Notice that c was some point that our line passed through, and a is actually going to be a position vector that our line passes through. And I'll explain what those will be. And in our coordinate geometry equation of a line, x was some variable, which is the same as t, and b was the direction, the gradient, and that's what actually b is. It's the direction vector. So there's a lot of similarities between these two, because it's actually the same. It's the equation of a line, just in a vector format. Okay, so these coordinates, they actually can also be written in position vector form. So the position vector of OA just means what was the journey that we had to go through to go from the origin, which is 000, to point A, and that would just be 1, 2, 3. We know we can turn a coordinate into a position vector quite easily just by making it a vector form. So OB would be 5, 4, -2. So if we want to find the equation, the vector equation of the line that passes through A and B, we need two things. Some position vector, so it's some position that our vector will pass through, and it will pass through both A and B, so we can choose either OA or OB. And then we need a direction vector. And to find the direction vector of a line, it's just going to be the vector from A to B. Because if we think about what A and B are in space, A would be some coordinate here, B would be some coordinate here, and the direction would just be the vector A to B, and then multiplied by some length, some variable t, which means it can go this way or this way across the line. Okay, so let's first find the vector AB. Now AB is just the journey from A to B. Now you can use your vector addition and subtraction here by going OB minus OA, and we can solve for that. Or it's just as simple as thinking, how do we get from 1 to 5? Well, we go positive 4 units. How do we go from 2 to 4? Positive 2. How do we go from 3 to -2? We'd go down 5. So that is going to be the journey from A to B. Okay, so that's all we need. We need a direction vector, which is this, and we need a position vector, which we can choose either OA or OB. So the vector equation of our line will be R equals, and we put our position vector that we're going to choose. I'm just going to choose the first one, 1, 2, 3. You could have chosen 5, 4, -2. That's fine. Plus, and we leave the t as our variable, just like we had x. And we put our direction vector, which will be AB, 4 to -5. So this is it. This is the answer of our vector equation of a line. And what this tells us is that if I give you any any time for t, if it's a time question, or if I want to sub in any value here for t, we can actually work our way across each of these lines, the top line, the second line, the third line. These are called parametric equations, and we can actually get a number for all of them. If t was, for example, 2, 1 plus 2 times 4, 2 plus 2 times 2, 3 plus 2 times negative 5, and that answer is where we will be on the line when t equals 2. So just like if we had a straight line back in coordinate geometry, if I subbed in an x value, you can find a y value. That would be some point. And it's the same thing here. If you sub in a value for t, you will find where you are in space on our vector equation of a line. So this is just a brief introduction. I think this topic does start to make more sense once you practice more questions. So try and practice a few questions where they have vector equations of lines. And then we're going to start having questions where these lines may intersect with each other. You might have two lines and they intersect at a certain point, and those points are very interesting. Okay, good luck.